Hello viewers, you're welcome once again. We are still under logic, Christ Almighty God's Algebra. Today we are going to treat law of absorption. Law of absorption. We have two types of law of absorption. One is law of absorption by conjunctive statement and law of absorption by disjunctive statement. We are going to start with law of absorption by conjunctive statement. Let us start. Law of absorption. Law of absorption. P and bracket P or Q is equal to P. So this is an example of law of absorption by conjunctive statement. We say that P and bracket P or Q is equal to P. What makes this law or this statement to be law of absorption by conjunctive statement is because of this connective and connective that connects the first conjunct P and the second conjunct P or Q together as a conjunctive statement. That's why it's called law of absorption by conjunctive statement. Let's prove this statement that it is true that P and the bracket P or Q is equal to P by law of absorption. That means it's equal to P. That it is law of absorption by conjunctive statement. Proof. Suppose suppose P and bracket P or Q is equal to P. We are assuming that statement is true. That is P, so that is P and bracket P or Q is equal to P. We are assuming that statement is true and it's a hypothesis. We are going to prove this hypothesis that it is true that P and bracket P or Q is equal to P by assuming that it is true. If you look at this equation, you find out that whenever the left hand of the equation is true, also the right hand of the equation is also true. In the same vein, whenever the right hand of the equation is false, also the left hand of the equation is also false. We say they are logically equivalent. That means they are equal. Since this statement is they are equal to each other, I mean both sides are equal to each other, we are going to transform it to by conditional statement, and it will still preserve truth. Since we assume that it is true, that is, we assume that this is true. So when you transform it to by conditional statement, it will still preserve truth. If and only if P and bracket P or Q, if and only if P is tautology by logical equivalent. We have now transformed this equation to biconditional statement, and it's still truth, it's tautology, in the sense that whenever the left equivalent is true, the right equivalent must also be true. Whenever the left equivalent is false, also the left equivalent must also be false. So if you write this statement, there's no possibility of getting falsity, always truth. You say that it is tautology. Being justified by logical equivalence, it is true logical equivalent that will transform this equation to biconditional statement. That's why I say it's being justified by logical equivalence. If and only if P or P and bracket P or Q implies P is tautology. By logical implication. We have now transformed this biconditional statement to conditional statement, and it still preserves tautology. In the sense that whenever the antecedent is true, the consequent must also be true. So if you write this statement, there is no possibility of getting falsity, always truth. You say that it is tautology, being justified by logical implication. It is through logical implication that we transform this conditional statement to this biconditional statement to conditional statement, and is still equivalent. That's still truth. If and only if P and bracket P or Q is logical implication of P. Since this is a conditional statement and it's tautology, this conditional statement since it is tautology, we can then derive that the antecedent is the logical implication of the consequent by principle of logical implication. So, reason is that this antecedent is a proper implication of the consequence. Since it's a proper implication of consequence, we say it is certain that antecedent exists. That's what it is certain that the antecedent exists. It means that antecedent is logical implication of the consequence. So if this is true, this also must also be true. If and only if P and bracket P or Q is equal to P and bracket P or Q. That means the logical implication is equal to itself, and it is true that logical implication is equal to itself because it is equivalent. I mean, they are logical equivalent. In the sense that whenever the left hand side of logical implication is true, also the right hand side of logical implication is also true. In the same vein, whenever the right hand side of logical implication is false, also the left hand side of logical implication is also false. We say that it is logical equivalent. So being justified by identity, that means the sameness. Being justified by identity, that means the sameness. If and only if P and bracket P or Q is equal to P and bracket P or Q and bracket P bracket not bracket Q or not Q. Now you see that we have, what we did here is that this P and bracket P or Q, we AND tautology with this P or Q. This P or Q, we AND tautology to it, and it still is same as P or Q. By law of identity, you see the same thing. So nothing has ever changed. The two set of equations are still equivalent. So being justified by law of identity. If and only if P and bracket P or Q is equal to P and bracket P upon Q and P upon Q, or sorry, it's only one open bracket, and and bracket Q or not Q. We transform this P or Q, that means this disjunctive statement, to conditional statement, and it just is equivalent. That means you substitute P or Q with P upon Q. That means P or Q, the disjunctive statement, substituted with the conditional statement, Q implies P. We then bring down the Q or not Q, and it still preserve equivalent. The posture of equivalent, that's still equivalent. Being justified by first Ejike's law. Being justified by first Ejike's. So it is through first Ejike's law that we transform this conditional statement P or Q to this disjunctive statement P or Q to conditional statement Q implies P. If and only if P and bracket P or Q is equal to P and bracket P and bracket Q or not Q upon Q. So this is not, sorry, it is not Q. It is not Q, please note. So that is equivalent. It is not Q implies P. So whether it is the equivalent to it, it is not Q implies P. So not Q implies P. Is not Q implies P. So what is it that we distributed this Q, not Q, here to the second conjunct Q or not Q. So that's what he did here. He just distributed this not Q to the second conjunct. And it's still logical equivalent in the sense that this is tautology. Tautology and with any term is the same at that time. That means it's equivalent to P. And this P and P is P, which is equal to the left-hand equation based on our assumption. So being justified by distribution of implication. So it's through distribution of implication that we distributed this not Q to the second conjunct, Q or not Q. That's why I have Q or not Q upon not Q. So it's being justified by distribution of implication. So if and only if P and bracket P or Q is equal to P and bracket P and. Now we are going to revise this conditional statement to disjunctive statement. Reason is that this implication, not Q, is being generated from the disjunctive statement P or Q. So whenever I want to revise it, it's going to be in disjunctive statement. So this conditional statement now we revise to disjunctive statement. That to say we are going to have bracket Q or bracket Q or not Q. You have now revised the statement to conditional state. Sorry, to revise this conditional statement to disjunctive statement. Now I have Q or bracket Q or not Q. Being justified by first education law. Being justified by first education law. So it's through first education law that we transform this conditional statement to disjunctive statement. If and only if P and bracket P or Q is equal to P and bracket P and bracket Q or T. We see that we have substituted this Q or not Q with T by law of complement. Through law of complement, substitute this Q or not Q with T. That's why I have P and bracket Q or T. Being justified by law of complement. We go to this side. If and only if P and bracket P or T is equal to P and bracket P and T. You see that this Q or T, so you substitute it with T because it's by law of constants. So whenever T is all with n times same thing as T, so it's being substituted with Q or T, it's substituted with T, being justified by law of constants. by law of constant. If and only if P and bracket P, so this is Q. This is Q. P or Q is equal to P and P. You see that this P and T is associated with P. P and T is associated with P. So they are logical equivalent by the law of identity. So whenever T is AND with any term, is written as that term. So being justified by law of identity. If and only if P and bracket P or Q is equal to P. So spell this P and P with P. They are logical equivalent by law of idempotent. So it's being justified by law of idempotent. It's two law of idempotent that substitute this P and P with P. Being justified by law of idempotent. Now I have now proved our hypothesis that our assumption that P and bracket P or Q is equal to P. I have now proved it. Now we then conclude, say thus P and bracket P or Q is equal to P. So we're going to prove the converse so that we can establish by the principle of essentiality that P and bracket P or Q is equal to P. Is law of absorption by conjunctive statement. So we're going to prove the converse. So let us prove the converse. So it's a conversely. Conversely, conversely, P is equal to P and bracket P or Q. So this is the converse of this. You see that P and bracket P or Q is at the left side of the equation here. Now P and bracket P or Q is now at the right side of the equation here. P at the right side of the equation here has now become P here at the left side of the equation. You say that it is converse. So we're going to prove the converse. So by the principle of essentiality, we then establish that P and bracket P or Q is equal to P is law of absorption by conjunctive statement. Now we're going to assume that this statement is true. So suppose P is equal to P and bracket P or Q. So we assume that statement is true. We assume that this statement is true as our hypothesis. I'm going to prove that it is true. You see that it's an equation. It says that whenever the left hand of the equation is true, also the right hand of the equation must also be true. In the same vein, if the right answer of the equation is false, also the if the right answer of the equation is false, also the left answer of the equation must also be false. We say that logical equivalent, that means they are equal. So since they are equivalent, we are going to transform it to biconditional statement, and it will still preserve truth. It will still preserve truth. If and only if P, if and only if P and bracket P or Q is tautology. Now, we have now transformed this equation to biconditional statement and its tautology. It says that whenever the left equivalent is truth, also the right equivalent must also be truth. In the same vein, whenever the right equivalent is false, also the left equivalent must also be false. If you implement this statement, there is no possibility of getting falsity. Always truth. You say that it is tautology, being justified by logical equivalent. So it's through logical equivalent that we transform this statement, the equation to a biconditional statement. So you say being justified by logical equivalent. Being justified by logical equivalent. If and only if P implies P and bracket P or Q is tautology. You see that you have now transformed this biconditional statement to conditional statement and it still preserve tautology. In the sense that whenever antecedent is true, the consequent must also be true. So if you break this statement, there's no possibility of getting falsity. Always truth. You say that it is tautology. Being justified by logical implication. It is through logical implication that we transform this biconditional statement to conditional statement. So being justified by logical implication. Being justified by logical implication. So if and only if P is logical implication of P and bracket P or Q. Now, we have now derived that P is logical implication of P or bracket P or Q. That means the antecedent is logical implication of the consequent through principle of logical implication. We establish that P is logical implication of P and bracket P or Q. In the sense that whenever, since this is a conditional statement and it's tautology, whenever it means that P is proper implication of the consequent. So we then say that it is certain that P exists. And if certain that P exists, it means that P is logical implication of the consequent. That's why I say that P is logical implication of P and bracket P or Q. So if and only if P is equal to P. That means P is equal to itself. I mean, the logical implication is equal to itself. And it is true that the logical implication is equal to itself. in the sense that whenever the left hand side of the logical application is true, the right hand side of logical application is also true. In the same vein, whenever the right side of logical application is false, also the left side of logical application is also false. It's said that it's logical equivalent and it is equivalent. So it is true that they are equal. Being justified by identity, I need the sameness. Being justified by identity. So if and only if P is equal to P and the P. Now explain this P with P and the P through law of idempotent. So through law of idempotent, you split P with P and the P. So be justified by law of idempotent. Go to this side. If and only if P is equal to P and bracket P or bracket Q and not Q. So it's still equivalent. Both applications are still equivalent. We all this P, the second conjunct, we all it with falsity. And whenever falsity is up with any term, it's sent at that term through the law of identity. Through law of identity. So it means that P or bracket Q and not Q is equal to P, and P is equal to P. So that's still logical equivalent. So be justified by law of identity. If and only if P is equal to P and bracket P or bracket Q upon Q. You see that I have now transformed this Q and not Q to conditional statement, and it still preserve equivalent. It's not yet, it's still law. It's not yet, it's not grace. It says that the two side of equation they are still equal because Q upon Q, that means Q implies Q is tautology. Tautology of any time is same as tautology. Tautology and with any time is same at that time. So it's equivalent to P, and P is equal to P. So being justified, it is through Christ Almighty God's grace that we transform this Q and not Q to conditional statement. Being justified by Christ the Almighty God's grace. So if and only if P is equal to P and bracket. Now we are going to distribute this Q to the first disjunct P. That is going to be P upon Q or Q. Yeah, you see that I have distributed this Q, this implication Q to the first disjunct P. That way I have P upon Q or Q. That means Q implies P or Q. And is C equivalent to this is P upon Q or Q is equivalent to tautology and with 8 times sentiment at that time. So we justify by distribution of implication. If and only if P is equal to P and brackets. Now we are going to revise this conditional statement to conjunctive statement. We are going to revise this conditional statement to conjunctive statement. Reason is that this Q, this implication Q, is generated from the conjunctive statement. So whenever I want to revise it, it's going to be in conjunctive statement because this is conjunctive statement. It is from here that we generated this Q. So we have P bracket P and not Q or Q. So we justify by Christ Almighty God's grace. It is through Christ Almighty God's grace that we transform this conditional statement to conjunctive statement. So we justify by Christ Almighty God's grace. Christ the Almighty God's grace. We continue to the other side. So if and only if P is equal to P and bracket, you see that this P and not Q or Q is equal to P or Q through second educators law. Through second educators law, P and not Q or Q is equal to P or Q. So is P or Q. So we substitute this P and not Q or bracket P and Q or Q with P or Q by second educators law, being justified by second educators law. We see that I have now proved our hypothesis that is P is equal to P or bracket P or Q, which is our converse. That P is equal to P and bracket P or Q. We then conclude. We say thus P is equal to P and bracket P or Q. Now, having proved the converse, we then establish by the principle of externality that P and bracket P or Q is equal to P. So therefore, P is equal to P and D bracket P or Q is law of absorption by conjunctive statement. So you have now proved that P and bracket P or Q is equal to P is law of absorption by conjunctive statement. Having proved the law, at this juncture, we withdraw our curtain. Thank you, viewers.